Games such as chess or card games or rock, paper, scissors can be analyzed using game theory, which is why the field is called game theory. But when we use the term game in game theory, we mean much more than social games such as chess or poker. For us, a game is any situation in which two or more players take actions, and the outcome for each player can depend on the actions of the other players as well as his or her own action. Such a situation is called a strategic situation because players have to think about what the other players are likely to do and what the other players are likely to expect other players to do. In contrast, a situation in which one player makes choices and the outcome depends only on her own choice is called a decision problem. A decision problem may involve uncertainties such as the roll of a die, but a decision problem does not involve another player who takes actions, aware of the game and the strategic nature of those actions. To describe a game, we need to say who the players are, what actions are available to each player, and what players' preferences are about the various combinations of actions. Preferences over combinations of actions are sometimes described using numbers called payoffs or utilities. Actions are sometimes referred to as strategies. When a game involves multiple stages or rounds, we also need to describe the timing of those stages, that is, who moves when. Games that have a temporal aspect are called extensive form games. For now, let's consider games that don't involve time. Such games are called simultaneous move games because players choose their actions without knowing anything about other players' choices. The simplest kinds of games involve only two players and two actions available to each player. Two-player games can be described very concisely in a table. Let's look at an example. Snickers and Reese's are competing candy bars. The two brands are deciding how much to advertise. Each can choose to advertise less or more. If they both advertise less, their brands will still be well known. But if one advertises more while the other advertises less, the more aggressively advertising brand will gain market share and make more money at the expense of the other brand. If they both advertise more, neither gets any extra advantage because their aggressive advertising efforts cancel each other. However, they both incur the higher advertising expense, leading to lower profits. Now, let's represent this game in a table. Who are the players? Snickers and Reese's. What actions are available to them? Snickers can choose to advertise less or more, and Reese's has the same actions available. And what are the players' preferences regarding various combinations of choices? If they both advertise less, their brands are well known and neither brand gains extra advantage, so they have the same high profits. If Snickers advertises more and Reese's less, Snickers gains extra advantage, so it has even higher profits, but Reese's suffers. If Reese's advertises more and Snickers less, Reese's gains and Snickers loses out. Finally, if they both advertise more, they incur high expenses but without much gain in sales, so they both end up with the lowest profits. So, each player's top preference is to advertise more while the other player advertises less. Each player's second-ranked combination would be for both of them to advertise less. The third best is for both to advertise more. And the worst outcome for a player is to advertise less while the other player advertises more. In this game and in many others, it is natural to describe players' preferences using monetary outcomes and assuming that each player prefers more money to less. But that's not the only way to describe preferences over actions. Often we use some arbitrary numerical scale to show how players would rank the various combinations of actions. In those cases, we call the numbers we use to show preference utilities or payoffs. Now that we have described the strategic situation faced by Snickers and Reese's as a game, we can ask the question, how would or how should these players act in this game? Let's take the perspective of one of the players. As Snickers, you might say to yourself, I don't know what Reese's will do, but they have two possible actions, advertise more or advertise less. I'll consider each possibility separately. What if Reese's advertises less? Well, I could also advertise less, but I would actually get a higher profit if I advertised more while Reese's advertises less. If they advertise more, what action should I choose? I would be better off if I also advertised more, because I have a higher profit when we both advertise more than when Reese's chooses more and I choose less. So it seems that whatever Reese's chooses to do, I would be better off advertising more. The reasoning we just went through shows that advertising more leads to a higher payoff for Snickers than advertising less would, and this is true whatever action Reese's chooses. A strategy that is the best choice for a player regardless of what other players do is called a dominant strategy. So advertising more is a dominant strategy for Snickers. It is not difficult to see that the same is true for Reese's. When a player has a dominant strategy, it seems very reasonable to expect that strategy to be chosen by the player. In fact, how could a player justify using an action other than the dominant strategy? Compared to any other choice, the dominant strategy is a better one, no matter what the other players do. So in this game, we would expect that both Snickers and Reese's would choose their dominant strategies, which is to advertise more. What makes this interesting is that as a result, they will both end up with lower profits than they could achieve by agreeing to advertise less. So why don't they agree to advertise less? If they did agree, each of them would have a strong incentive to cheat on the agreement and gain extra advantage by advertising more. That is, they could agree to advertise less only if someone, an independent third party, enforced that agreement to prevent cheating. But such a third party enforcer is not part of the description of this game. If there were such an enforcement mechanism available to the players, we would be looking at a different game. The game we just analyzed is a version of the prisoner's dilemma. In a prisoner's dilemma game, players have a dominant strategy that leads to a suboptimal outcome, just like in this game. Versions of the prisoner's dilemma appear in many contexts, so this type of game is often studied.